Hello and welcome to Life at Pulse. Today we will go over a GED Science practice test, and in this screencast we will go over the first 12 of the around 40 questions. Let's start. The first question is, as we can see, about cells. So we have a very detailed illustration of a cell here, and the question is, what is the function of the cell wall? So we get a lot of information here. You can see the cell wall is right here, and this is a question that asks us for some factual knowledge that we need to know. We need to know some basics about cells, and one of these basics is knowing about cell walls. So the possible answers are to build proteins, to convert solar energy into chemical energy, to protect and provide support for the cell, or to take in carbon dioxide. Now, the cell wall is something that's unique to plant cells. Animal cells don't have cell walls. Fungi cells have cell walls, bacteria have cell walls, but yeah, plant cells have cell walls as well. And we can see that this here is a plant cell with a cell wall. It has chloroplasts as well, which are unique to plant cells, and a large vacuole. So these are the three main features of plant cells that animal cells don't have: the cell wall, the large vacuole, permanent vacuole, and the chloroplasts. And the function of the cell wall is to give support and protection to the cell. The other ones are to take in carbon dioxide, so the structure that regulates what moves in and out of the cell is usually the cell membrane. Now, all cells have a cell membrane. See up here, the cell membrane regulates what comes in and out of the cell. Building proteins, this is done at the, we have somewhere here ribosomes. No ribosomes specifically, but we have a rough endoplasmic reticulum, and on the surface of the rough endoplasmic reticulum are ribosomes. So this is where proteins are built. Convert solar energy into chemical energy. This is called photosynthesis, and this is done at the chloroplasts. So cell wall protects and provides support to the cell. Question 2 and 3 are based on the following information. The following reaction takes place in a reaction vessel. Substance A is a solid and reacts with a liquid, and heat is applied to the reaction to form two different solids, C and D. The chemist who carries out the reaction in the laboratory repeats the experiment under various conditions in order to produce the maximum possible amount of substance C and D. This reaction can be classified, first of all, as an endothermic, exothermic reaction, or an equilibrium, or as a nuclear reaction. So a nuclear reaction is a reaction where an atom itself breaks down, its nucleus breaks down into different elements. This is not the case here. We have two different substances reacting with each other to form two new substances by rearranging the atoms of the substances, but not changing the atoms themselves. So it's not a nuclear reaction. At equilibrium, reactions that can be at equilibrium are reversible reactions. Reversible reactions are indicated with two arrows like this. Since we have only one arrow in one direction here, that means that the reaction is unidirectional, not reversible, and goes to completion. From this side, reactants will all react to form products. And these reactions don't usually have an equilibrium position. So reversible reactions can be at equilibrium. That means when they are balanced, when the forward reaction has the same rate as the reverse reaction, and the concentrations of both reactants and products don't change anymore, then a reaction would be at equilibrium. But we don't have a reversible reaction here, so equilibrium is nothing that a unidirectional reaction can be at. So it's either exothermic or endothermic. Exothermic means heat is given out by the reaction. Endothermic means heat is taken in by the reaction. And we can see that heat is on the reactant side here, which means heat is supplied to the reactants for the reaction to happen. Therefore, heat is taken in by the reaction, and our reaction is an endothermic reaction. Question 3 relates to the same piece of information. Which of the following factors will not help the chemist to change the speed or the rate of the reaction? So factors that affect the rate of reaction are temperature, surface area, which is either large pieces or powdered reactant, pressure, catalyst, and one factor that is not mentioned here is concentration. So all these factors affect the rate of reaction. Now the question is, in this specific reaction, which of the following factors will not help the chemist to change the speed of the reaction? So increasing the temperature of the system, increasing the temperature means our particles move faster, they have more energy, therefore they collide more frequently, collisions are more energetic, and that will increase the rate of the reaction. So answer A does increase the rate of reaction. Using a powdered reactant, since we have one of our reactants as a solid, if we make this solid from large chunks into small powdered pieces, the sum of all powdered pieces together will have a larger surface area, so more of the reactant is going to be in contact with the liquid reactant, therefore there will be more frequent collisions and the rate of reaction will be faster. Collisions between reacting particles. Adding a catalyst. A catalyst is a substance by definition that speeds up the rate of a reaction and is not changed or used up by the reaction itself. So adding a catalyst always will speed up the rate of reaction. So it's not A, B, and D. Increasing the pressure on the system. So why does increasing the pressure on the system in this case not speed up the rate of reaction? Now if we have a solid or as well a liquid, and we apply pressure to the solid or the liquid, nothing really changes about the solid or the liquid under pressure. Solids and liquids are not compressible. Gases, on the other hand, if we have a gas and we increase the pressure on a gas, imagine you have a balloon and you take it underwater and you pull the balloon underwater a couple of meters, what will happen? The pressure on the balloon will compress it and press the air in the balloon closer together, so the air particles will get closer together. So pressure in this case is a factor that only affects gases. So if we had a reaction where our reactants would be gases instead of solids, then pressure would have an effect on the rate of the reaction. However, we have only solids and liquids as reactants and products, and therefore pressure does not have an effect on the rate of reaction. In the end, we can say that pressure is actually the same as concentration. So if we increase the pressure on a gas, we push the gas particles closer together, and therefore we have more particles per unit volume, and that is what concentration is. Concentration is a measure of the particles per unit volume. So increasing the pressure on a gas increases the concentration of the gas. One more time, because we do not have a gas here in either reactants or products, therefore pressure does not have an effect on the rate of this particular reaction. Question 4, which equation is not correctly balanced? So a balanced equation has to follow the law of conservation of mass on matter. We need the same amount of atoms on both sides of the equation of each element. We can see the first reaction has 1 carbon and O2, which means 2 oxygen atoms, and on the product side we have CO2, 1 carbon and 2 oxygens, and we can see this equation is balanced. So it's probably the correct answer. Let's quickly check the other ones here. Na, so we have 1 Na here, Cl2, 2 chlorine atoms gives 2 NaCl. So 2 NaCl means 2 times NaCl. We can see when we have 2 times NaCl, we have 2 Na and 2 Cl. However, on the reactant side, we have only 1 Na. So to balance that, we would have to add a 2 in front. So this is not balanced. Ca plus... Oh, which equation is not correctly balanced? So we've just found it. The second one is not correctly balanced. So A is correctly balanced, B is correctly balanced as well. It's exactly the same as A. 1Ca, 2Cl gives CaCl2. And here we have, this one is a bit more tricky, but we can quickly go over it. We have 3 times O2. So if we have 3 times O2, then we have a total of 6 oxygen atoms. React to form 2 times O3. So O3 is a molecule that has 3 oxygen atoms. If we have this 2 times, we have a total of 6 oxygen atoms as well. So on both sides of the reaction, we have 6 oxygen and 6 oxygen. The product side too. So this one is balanced. The only one that is not balanced is B. The Centers for Disease Control recommends that children in the United States receive certain vaccinations at given ages. Several of these vaccinations are repeated at specific intervals between birth and age 6. Many of these diseases for which children are routinely vaccinated today used to pose serious health concerns in the past. However, since vaccinations began, some of these diseases have declined by 100%. For example, in the years just prior to the introduction of the measles vaccine, more than 503,000 cases were reported annually. In 2007, there were only 43 cases of the disease. Okay, our table here is not completely in the image. Let's change this a little bit. So according to the information given, which of the following can be most properly inferred? Children receive the vaccinella vaccine on the same schedule at which they receive the measles, mumps, and rubella vaccine. Children receive the rotavirus vaccine on the same schedule at which they receive the pneumococcal vaccine. All children receive the meningococcal vaccine between ages 2 and 6. The influenza vaccine is not given to children in high-risk groups. So, to be able to answer this question, we have to understand this table here. And to understand this table, let's have a look at this. So we can see the different vaccines that are given and the ages here on top at which the vaccines are supposed to be given, and then we can see the time frame or the age at which the vaccine should be given. So some of these are just letters in boxes, and this refers to specific ages at which the vaccines should be given. So rotavirus vaccine should be given 3 times to an infant at age 2 months, 4 months, and 6 months. Some other vaccines can be given over a longer or in a longer time frame, in a longer range. So, for example, if we look at the hepatitis B vaccine, one vaccine should be given at birth, and then a second vaccine should be given somewhere between the ages 1 and 2 months, and the third vaccine should be given somewhere between the ages 6 to 18 months. Then we have two different color schemes as well. We have light gray background and black background, and we are told down here what this means. A gray background means a range of recommended ages for all children, and a black background means a range of recommended ages for certain high-risk groups. So let's have a look at the question again. Same schedule, Vaccinella vaccine and measles, mumps, and rubella. So let's have a look. Vaccinella is... Where is Vaccinella? Here. Vaccinella is here, measles, mumps, rubella is here. And we can see that this looks like the same schedule. So somewhere between 12 and 15 months in both cases, and then again somewhere between 4 and 6 years. So answer is probably correct. If we compare rotavirus and pneumococcal vaccine, rotavirus here, pneumococcal here, so rotavirus has 3 vaccines, pneumococcal 3 vaccines, but a 4th vaccine between 12 and 15 months, so it's not the same schedule. All children receive meningococcal vaccine between the ages of 2 and 6. Meningococcal is down here, and meningococcal vaccine is only given to children in high-risk groups. That is not all children, so that's wrong. The influenza vaccine is not given to children in high-risk groups. Influenza here, gray background. Gray background means range recommended for all ages, for all children, for all children. That includes high-risk groups. All children means including the high-risk group children. So that means D is wrong as well. So A is the correct answer. According to the information given, which is a true statement, children receive the rotavirus vaccine 1 time between ages 2 and 6 months. Rotavirus vaccine here 1 time between 2 and 6. No, they receive it 3 times, so that is wrong. All children should receive the meningococcal vaccine between 2 and 6. We already answered that in the question before. It's only high-risk group, not all children. This one here, high-risk group. Children are vaccinated against diphtheria, tetanus, and pertussis 4 times before the 2nd birthday. Diphtheria, tetanus, pertussis 4 times before their 2nd birthday. 1, 2, 3, 4. 2nd birthday is somewhere here between around 24 months. So yes, they receive 4 vaccines. So that is the correct answer. D, hepatitis B vaccine must be repeated at ages 6, 12 months, 15 months, 18 months. Hepatitis B must be repeated at ages, no, so we see already 1 and 2 months, and then somewhere between 6 and 18 months again, but not every time. It's a range of which it should be done, so not D. The patient receives the same vaccination each winter. According to the chart, which disease is this vaccination preventing? So if we look at the chart, the only vaccine that has something special here written is influenza, which says yearly. So it's given between 6 months and 4 to 6 years at some point, and then should be repeated yearly. So influenza is the correct answer. Diphtheria, a disease caused by bacteria found in the mouth and throat, causes patients to suffer from a sore throat, as well as fever and chills. Untreated, it can lead to complications including heart failure and paralysis. It can be fatal in approximately 10% of those who contract the disease and used to be a major cause of death in children. As recently as 1920s, about 15,000 people died from diphtheria each year. Which assumption can be made regarding this disease? Diphtheria somewhere in here? Yes. So we are now getting vaccinated against diphtheria. So more people die from diphtheria today than 100 years ago? Probably not, because we do have a vaccine nowadays. So no more people have to die from it. The diphtheria vaccine has eliminated sore throats among young children. That is probably not correct, because other pathogens can cause sore throats as well, not only diphtheria. Diphtheria was the most serious health concern facing people in the 1920s. We're just told that as recently as the 1920s, about 15,000 people died from diphtheria each year, but we are not given any information about any other diseases that may have killed more people. So yeah, we just don't know, don't have enough information. Widespread use of the diphtheria vaccine has significantly reduced its threat. That is definitely correct. Using the vaccine has reduced its threat. Pertussis, also known as whooping cough, looks like the common cold. However, after a few weeks, it causes patients to suffer violent coughing spells and may lead to pneumonia, seizures, and brain infections. In some cases, it can be fatal. It is spread through the air from one person to the next, but can be prevented through vaccination. Which type of disease is pertussis? So it's age-related, environmental, hereditary, or infectious. It is an infectious disease. How do we know? Because it can be spread through the air from one person to the next. That is an example of an infectious disease. Number 10. When comparing mitosis and meiosis, you can say that both processes, so you see mitosis, you see meiosis. You can see that mitosis at the end produces two daughter cells that are 2N. 2N means diploid, which means the cells have two sets of chromosomes, one set from the father, one set from the mother. Meiosis, we can see has two divisions, which produces 4 cells at the end. And we can see that looking at the pictures, we start with the same number of chromosomes here, and the daughter cells in mitosis still have the same number of chromosomes, so diploid cells make diploid cells. We can see that in meiosis, however, the number of chromosomes has been reduced from 4 in this case to 2 in the daughter cells. So when comparing these two, we can say that both processes produce the same number of daughter cells. No, this produces 2 and this produces 4. 2 and 4. Produce sex cells with the exact same number of chromosomes as the parent cells. No, the statement in general is wrong. So the sex cells are these here. These are sex cells. And this is what meiosis is for. Produces sex cells that have half the number of chromosomes as the parent cell. They're haploid. He is wrong. Involve the replication of DNA. Replication, replication. So that sounds great. Yes, both involve replication of DNA. If we want, after mitosis, the same number of chromosomes in 2 cells, that means that before this is possible, the DNA needs to double. We'll have mutations, not necessarily. So C, the correct answer. Next 2 questions, or the last one for the screencast, are based on this food web here. What is the role of the mole in the food web? The mole is right here. And we can see that it feeds on slugs, and the slugs feed on leaves. Therefore, is the mole a secondary consumer, decomposer, tertiary consumer, or primary consumer? It is a secondary consumer. The leaves are the producers. That's what every food web and food chain starts with. Producers are eaten by primary consumers, and primary consumers are eaten by secondary consumers. So therefore the mole is a secondary consumer. During which link in the food web is the most energy transferred? So this is something that we need to know about food webs and food chains. Every organism needs energy to stay alive, for metabolism and so on. So whenever an organism eats something, it will use a lot of this energy up, and in the end, terminally this energy will end up as heat and will be lost to the surrounding. So the largest transfer of energy that we have is always from the producer level to the primary consumer level. And then with every trophic level, with every next level, the amount of energy transferred gets less. So therefore we are looking for a transfer from producer to primary consumer, and the example of that is nectar to butterfly. Producer, primary consumer. Okay, we're finished with our first part of the practice test for science. Hope to see you next time, and yeah, I hope I could help you for your preparation for your GED science test. Until then, have a good day.